Shalom to you again. This is part 2 of the review video. Here we continue solving problems on chapter 12. So we're going to complete the square, solve quadratic equation by completing the square. So first of all, we need to write set y equal to 0. So we're going to write x squared minus 4x minus 77 equal to 0 because we are looking for x-intercept. X-intercept is when y is 0. And then because we are completing the square, we want to move all the constant on one side. So we are going to add 77 to both sides. And that will give us x squared minus 4x. And we're going to leave a room where we're going to add on what we are going to get after we complete the square. Okay, so remember how it goes. You take the coefficient of the linear function. The linear one is the one with x, just x. So we take half of it, and that half of it is going to be what we are going to square. So half of negative 4 is negative 2. So we put that negative 2 here and we square it. And then we take that negative 2, we square it, and we add it here. Negative 2 squared is positive 4. And whatever we do to one side, we do to the other. So now we have 77 plus 4, and that will give us 81. Okay, and now we have a perfect square. We have a squared, so we can go ahead and take the square root of both sides. And when we take the square root, we need to remember positive and negative. So square, we cross out square root. We have x minus 2 equals plus or minus square root of 81 is 9. And now we are going to add 2 to both sides. So we're going to have x equals, again, the left side is going to become 0 because negative 2 plus 2 is 0. So on the right side, we have positive 9 plus 2, which will give us 11. And then the second x is going to be negative 9. So again, one is positive, one is negative. So it's negative 9 plus 2, which will be negative 7. And so our x is going to be positive 11 and negative 7. And that's that one. Okay, now let's solve equation by completing the square. By the way, this asks whether will the vertex lie below, above, or on the axis. So we have two real solutions, and our A is positive. A is what is multiplying the coefficient of quadratic. Our A is positive. So the graph we're going to curve up. It's going to curve up. And they're going to cross the x-axis. So the vertex is going to be below. Vertex is going to be below the x-axis. Okay. So, all right, by quadratic, if ax squared plus bx, so x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And then we plug in, first of all, again, we need to make sure our equation is in standard form. So right now we have this stuff on the right side. We need to move it to the left side. So we're going to add 11t, and then we're going to add 2 also to both sides. So we're going to have 5t squared plus 11t plus 2 equals 0. So now we know our A is the number that is multiplying t squared, so which is 5. And our B is 11 multiplying the linear, and our C is 2. And then we just plug them into our equation. So B is 11, so we're going to put negative 11 plus or minus square root of 11 squared minus, try to put these multiplication stuff in parentheses, so you remember to multiply before you subtract. Okay, So it's 4 times A is 5, times C, which is 2, all over 2A. Again, A is 5. So x equals negative 11 plus or minus square root of 11 times 11 is 121 minus. Now 4 times 5 is 20. 20 times 2 is 14. All over 2 times 5 is 10. Okay, now simplify from inside out. Simplify the square root. Now 121 minus 4. 121 minus 4 is 81. So we're going to have 81, square root of 81 over 10. All right, you're going to kind of move up here. Keep working on that. So it's negative 11 plus or minus. Now square root of 81 is 9. All over 10. So now we can separate them. So 1x is negative 11 plus 9 over 10. So negative 11 plus 9 is negative 2 over 10, which will give us negative 1/5. So that will be one of our x's. 1x is negative 1/5. And then we do the other one. X equals negative 11 still. And then we have positive 9. No, we use positive 9 here, so we do negative 9. Negative 9 over 10. So that's going to be negative 20 over 10. And that will become negative 2. So our second x is negative 2. And that will be that. All right, let's solve a real-world application problem. The dimensions of a sheet of paper represented by 2 consecutive integers. Okay, a sheet of paper would have what shape? Rectangle. So again, draw the picture. It's going to be a rectangle. It's going to be 2 consecutive odd integers. So it's going to have only 2 dimensions, length and width. So if the length or if the width is W, what will be the length? So the odd integers goes what? In 2s. If the first one is W, the second one will be W plus 2. So it means the width is going to be W plus 2. And so the area is going to be length times width. And we are given that the area of the paper is 1/4. So we replace that with 143. And then we replace the length with this quantity, W plus 2. They go together. So put that in parentheses and then times the width, which is W. And now we can go ahead and simplify this to solve for W, and then we use that to find for length. So we can distribute the W. Okay, let me change the color a little bit here. So distribute the W into the W and 2. So 143 equals W times W is W squared plus 2W. And now you have a quadratic equation. Now, the constant is by itself. Why not we just use completing the square right away and do this? So we can do 143. And so 1/2 of 2 is 1. And 1 squared is 1. So just add that 1 equals we have W squared plus 2W plus the 1 squared is 1. So we added whatever we add to one side, we add to the other. And then we're going to simplify the left side. 143 plus 1, we get 144. Equals, on the right side, we're going to find the square, factor it. We're going to get W. Remember, is whatever we squared, half of 2, which is positive 1. So you're going to write 1 and the squared. And then we take the square root of both sides. So plus or minus square root of 144 is going to equal what? The square roots are going to cancel out the square. So we're going to have x plus 1. And now the square root of 144 is 12. So equals x plus 1. And now we are going to add 1 to both sides. So we're going to have 12. Subtract 1 from both sides. So you're going to have minus 1 and then minus 1. So we're going to have 12 minus 1 equals x. So that would be 11 equals x. And we can also have 12. Now, we used positive 12 here, so we're going to use negative 12. So negative 12 minus 1 is going to equal x. So it's not going to be negative 13 equals x. Change the x to w. It should be w, sorry. Okay, kind of go to x because we used to x, but this is w, okay? Is our w, and that's the width. The x is w, that's the width. Okay, that's our variable. So that's our w. Let's see. So, but then we see here the width cannot be negative. So we cannot take negative 13. So we reject it. We reject negative 13. So the width is actually just 11. And now to find the length, we do what? We add 2 to the width. We add 2 to the width, and that will give us 13. So the dimensions will be 11 and 13. Okay, now let's quickly go over the variations. Remember direct variations and the equations when y varies directly to x, and you have to have a constant. And when y varies inversely with x, x is going to be under. And when y varies jointly with x and z, there are two things. You always have a constant there. When it's combined is when you have both direct variation and inverse variation. Okay, y varies directly with z and varies inversely with x. Okay, let's do a quick question here. R varies directly as the cube of z. Okay, watch when it's cubed and when it's squared. You need to watch for those. So it's cubed t and the square of x. So r varies, so r equals, always keep the constant, the cube of t cubed, and the square of s. And then it's inversely, s is inverse. So we're going to multiply by 1 over x, s squared. Okay. And which can be simplified to k, t cubed over s squared. Okay, that's the equation. Now we're going to find k. So we gave us the condition when r is 1/2, k is 6, and t is 2. Substitute to find k. So when r is 1/2, we keep the k, and then we take the t, which is 2, and we cube it. 2 cubed. And we take the s, which is 6, and we square it. So 1/2 is equal k times 2 cubed is 2 times 2 is 4, and 4 times 2 is 8. So we're going to have times 8 over 6 times 6 is 36. Okay, and now we have 1/2 equals, so k times 8 is 8k over 36. And we can actually cross multiply and get 2 times 8k is 16k equals 1 times 36 is 36. We can simplify k is 36 divided by 16, which will give, it then simplifies a fraction 9 over 4 or 2.25. Okay, that's the k. And now we can go ahead and plug that into our formula to find r with the given information. So r equals 9 over 4 times t t cubed. So you have t cubed, so now t is 4. So it's going to be 4 cubed over 1 times, and the s is 12. So it's going to be 1 over, remember the s is inversely, so it's in the denominator. So it's going to be 12 squared. Okay, so and then we simplify. R equals, keep the 9, 4 times 4 times 4 is 64. And 12 times 12 is 144. Then multiply the numerator and multiply the denominator. The numerator will give 576. The denominator will also give 576. It just happened that way. Okay, so which is simplified to 1. So the radius will be 1, the r will be 1 when t is 4 and s is 12. Okay.